Welcome back, grade 7 and 8, to another one of Mr. Wensink's science videos. All chemical reactions involve a change in energy. Some reactions, such as rusting, take so long that we don't notice the change in energy. In other reactions, such as the explosion of fireworks, the change in energy is impossible to miss. All chemical reactions need energy to start. The energy needed to start a chemical reaction is called the activation energy. Heat is the activation energy for many reactions. For example, think about the reaction you observe in a sparkler. This is the reaction of magnesium and oxygen to form magnesium oxide that is needed to start this reaction. Without heat as activating energy, the sparkler would never ignite. Some reactions take place with so little activation energy that it seems as though none was used. These reactions are called spontaneous reactions. The chemical reaction that releases energy in the form of electricity in a battery is a spontaneous reaction. This is what makes batteries useful. They produce energy quickly without the addition of much extra energy. Activation energy is not the only energy involved in a chemical reaction. During a reaction, energy is also either released or absorbed. Reactions are classified as either exothermic or endothermic. An exothermic reaction is a chemical reaction in which energy, usually in the form of heat or light, is released. Combustion is an obvious exothermic reaction. It releases both heat and light. Another exothermic reaction is the reaction of hydrogen gas with oxygen gas to produce water. This reaction produces large amounts of heat. The energy released in an exothermic reaction is often written as a product in a chemical equation. For example, hydrogen gas plus oxygen gas becomes water and heat. The law of conservation of energy states that energy cannot be created or destroyed during a chemical reaction. So, where does this energy come from? The energy released during an exothermic reaction is originally stored in the reactants. Consider two equal-sized containers on a shelf in a chemistry stockroom. One has gasoline in it, and the other has water. The gasoline container has more potential energy because of the stored energy in the bonds of the gasoline molecules. This energy can change form. The potential energy stored in the chemical bonds of the reactants can be released during an exothermic reaction as kinetic energy in the form of heat. An endothermic reaction is a chemical reaction in which energy is absorbed. During an endothermic reaction, energy is stored in the products that form. For example, many reactions do not occur until the reactants absorb heat from their surroundings. Limestone, which is composed of the chemical calcium carbonate, does not usually react with its surroundings in nature, but it does not normally experience a lot of heat. But when limestone is heated, a chemical reaction converts the limestone into calcium oxide, or lime. Lime is a chemical used in water and waste treatment plants and in the manufacturing of paper products. Converting table salt into sodium and chlorine for manufacturing purposes is another example of an endothermic reaction. Photosynthesis is another endothermic process in which light energy from the sun produces glucose. The cells in our body use glucose to get the energy they need through cellular respiration, an exothermic process.